All right, let's jump right into a really mind-bending idea. What if an AI could teach itself how to get smarter? I mean, really teach itself. We're going to dive into this world of autonomous AI agents and a system called AgentEvolver that, well, it could literally change everything.
I mean, just think about it for a second. Imagine an AI that doesn't just, answer your questions. It actively completes complex tasks for you. We're talking booking your travel, managing your calendar, even helping you with coding. That's the incredible promise here, right? A future where these agents handle all the digital heavy lifting, which would just massively boost our own productivity.
Okay, so that's the dream. But here's the reality. There is a huge, huge problem. For all that incredible potential, the way we currently build and train these agents, it's just broken. I mean, fundamentally flawed. It's slow, it's expensive, and it is so inefficient. The dream is right there, but we've basically hit a brick wall trying to get to it.
So, to really get why the solution is so cool, we first have to understand the problem. Let's dig into the challenges that have been holding these AI agents back.
Right now, training one of these agents is just a painful slog. There are basically three big steps. First off, you need humans, real people, to manually create thousands and thousands of tasks. It's incredibly labor-intensive. Second, the agent just learns by, well, randomly trying stuff out. It's this brute force method that wastes a ridiculous amount of time and money. And then finally, to top it all off, the learning itself is super inefficient. So even when the agent does learn something, it has a really hard time figuring out which specific actions actually led to success. The whole thing becomes a giant guessing game. So all of this frustration, this inefficiency, it led some researchers to ask a really brilliant and, honestly, transformative question. They looked at this whole rigid, human-led process and said, hang on, why are we doing all the work? Why not just entrust the model itself with the autonomy to drive its own learning process?
And yeah, that single question is what leads us right here to a totally new system that just completely flips the script on how we build AI agents. It's called AgentEvolver. So the core idea behind AgentEvolver is actually beautifully simple. It's all about giving the AI the autonomy to learn by doing. Instead of us feeding it some pre-made, boring curriculum, AgentEvolver just lets the AI interact directly with its digital world. It lets it figure out what's possible and, in a way, design its own lesson plan from scratch. Okay, so how does it actually do all this? I mean, it sounds kind of like magic, but it's not. AgentEvolver is a really clever system built on three powerful interconnected ideas, or pillars, that work together to create this amazing continuous self-learning loop. All right, the first pillar is something called self-questioning, and this is exactly what it sounds like. The agent becomes its own teacher. Instead of just sitting around waiting for us to give it tasks, it starts exploring its environment out of pure curiosity. It's basically asking itself questions like, what can I do here? Or what happens if I click this? And this curiosity is what allows the large language model, the AI's brain, to generate its very own unique tasks to go and solve. The best way to think about this is like a little kid exploring a new room. There's no instruction manual, right? They just start touching things, pushing buttons, seeing what happens. And through all that playful exploration, they're inventing their own little games and tasks to figure out how the world works. That is exactly what self-questioning lets the AI do. Okay, so that brings us to the second pillar, self-navigating. Once the agent has come up with its own tasks, it still needs to solve them, right? And it needs to do it efficiently. This is where it starts learning from its own past. It doesn't just wander around aimlessly. Instead, it builds up this internal library of its own successes and failures and uses that to guide what it tries next. I love this analogy. It's like a seasoned explorer planning a new expedition. They don't just start walking into the jungle from scratch, do they? No. They pull out their old maps, they look at their journals, they remember which paths led to dead ends and which ones led to treasure. But learning from the past like that, every single new journey gets smarter and way more efficient. And that brings us to the third and final pillar, self-attributing. And this one solves that big problem of inefficient learning we talked about earlier. See, when a task has a whole bunch of steps, how does the agent know which specific action was the one that made all the difference? Well, self-attributing is the mechanism that lets the AI pinpoint the exact moves that led to a win or a loss. This one is kind of like a great sports coach reviewing game film after a match. A good coach doesn't just look at the final score and say, we won or we lost. Nope, they break the whole game down, play by play.
They'll credit that one perfect pass or point out that single missed block that changed everything. It's that kind of super detailed, fine-grained feedback that really truly accelerates learning. So that's the whole system, the 3 pillars. But here's the million-dollar question, right? Does it actually work? Do these things all come together to create a better AI? Well, the results are, frankly, they're stunning. Okay, if there's one thing to take away from the performance data, it's this. AgentEvolver creates smarter AI, not just bigger AI. This system lets smaller, more efficient models punch way, way above their weight class. They end up outperforming models that are significantly larger. And I want to pause here because this is a huge deal. It means we might not need these massive, incredibly expensive supercomputers to build capable agents anymore. And that opens the door for so much more innovation from so many more people.
All right, let's look at the proof in the pudding on this benchmark called App World, which basically tests how well an agent can use different apps. The AgentEvolver model, the one with 14 billion parameters, it clearly outperforms a standard model that's more than twice its size at 32 billion parameters. It is literally doing more with less.
And this isn't just some fluke, a one-time thing. We see the exact same story on another really complex benchmark called BFCL. Once again, the smaller, smarter AgentEvolver model comes out on top. This shows pretty consistently that having a better way to learn is way more important than just having more raw size.
So, where does this leave us? What does this all mean for the future of AI and for us? Let's just quickly wrap up with the key takeaways.
So, to sum it all up, the old way of training these AI agents is just too slow and expensive. It's broken. AgentEvolver comes along and fixes it by letting the agents basically teach themselves. They get curious with self-questioning. They learn from their past to work smarter with self-navigating. And they figure out exactly what actions lead to success with self-attributing. And the big result? We get more capable AI without just having to build bigger and better models. And that leaves us with a final and pretty powerful thought to chew on. For so long, we've been focused on building an AI that can learn. But AgentEvolver introduces an AI that can learn how to learn better. So the question isn't just about whether an AI can book your travel anymore. The real question is, what happens when that AI teaches itself a better way to book travel, and then a better way to code, and then a better way to do, well, everything? What happens when that self-improvement loop just keeps going forever?